Hello everyone and a very warm welcome to this video lecture series in which we are learning about how we can improve and optimize our neural network. So until in the previous video lecture, we have seen that what is exactly the mini batch gradient descent, and we have a very deep explanation on it, that what exactly and how exactly the mini batch gradient algorithm performs. So, apart from using gradient descent as a method to optimize your neural network, or in order to say that in order to get the global minima of the contour plots, there are a few more types of algorithm that we can use in order to optimize our neural networks. And in order to learn these algorithms, there are a few basic concepts that we need to focus upon first. And one of those concepts that we need to study early is the concept behind the exponentially weighted averages. So, exponentially weighted averages are often known as exponentially moving averages also. So, in this video lecture, we are going to see that what are exactly the exponentially weighted averages. And in the next video lecture, we are going to have a very deep explanation about what does exponentially weighted averages do and how they are exactly able to contribute to these advanced algorithms. So let us continue to watch this video lecture. So now in this slide, you can see here that you have been given here on the left hand side the temperature of a city. Okay. So these are the temperatures given to us. Okay. And here you can see if the first temperature is 40 degree Fahrenheit, then 49 degree Fahrenheit, then 45, then 56, and so on. So the theta values represent the temperature on a particular day of the year. Okay. So when this is the starting of the year, this is the 1st January, so it is theta 1. So theta 2, theta 3, that goes on till theta 181, and so on. It would go up to theta 365 also. Okay. This would have some temperature of approximately, suppose, say 41 degree Fahrenheit. Okay. And on the right side, you can see that here is given a graph to us. Okay. Now, this graph on the y axis, there is plotted temperature. Okay. And on the x axis, we have plotted days. So, what it generally happens that you can see that in the starting of the year, the days are quite colder. In the mid of the year, the temperature is quite high and the days are warmer. Okay. And in the ending of the year, again, it's the same temperature as the starting one, as the temperatures are low. Okay. As you encounter winters in the starting and the ending of the year only. Okay. So this is the temperatures you can see here. Okay. In variation with the days. Okay. Now, if I tell you that now you what you want to do is you want to plot the weighted averages of this temperature. So how you can plot or write some equation that would represent the weighted averages of these temperatures. So let us suppose that we set the initial temperature V0, okay, is equal to 0. Okay. So this is the baseline temperature or the baseline average temperature that we are setting up to. Okay. And if you need to find the temperature, average temperature V1, then I would write the equation as zero point 0.9 into V naught plus zero point 0.1 into theta 1. Okay. So the average V1 would be equal to zero point 0.9 times the previous temperature, that is V naught here. Okay. Plus zero point 0.1 times the current day's temperature, that is equal to theta 1. Okay. Similarly, if I need to write V2 here, then V2 would be equal to zero point 0.9 times of V1, which is the previous day's temperature, plus zero point 0.1 times of theta 2, that is the present days or the second day temperature. Okay. Now, if I write V3, then V3 would be equal to zero point 0.9 times of V2 plus zero point 0.1 times of theta 3, that is the third day's temperature. Okay. And that would go on. Okay, and if you need to write a generalized equation as v at the tth day, that would be equal to zero point 0.9 times of v of previous day's temperature, that is v of t minus 1, plus zero point 0.1 times of theta t, that is the present day's temperature. Okay, so what is basically the significance behind writing these equations is that these equations are now helping us to find out the weighted averages, okay, over the whole year. Now, for finding a temperature, that is, for finding the average temperature of a particular day, it is required that you give some weightage to the previous day's temperature also, and some weightage to the present day's temperature also. So, present day's temperature is in some ways related to the previous day's temperature also. Okay, so value of previous day's temperature is very much necessary for finding the exponentially weighted averages also. Okay, now let us see in a graphical manner so that it would be easy for you to understand that what is exactly the concept behind the exponentially weighted averages. Okay, so let us move to the next slide. So here what we can see, that if I need to write a generalized equation, so my generalized equation is Vt is equal to, there is some constant, let us suppose this constant is beta, beta times of v of previous day's temperature, okay, that is t minus 1, plus it's 1 minus beta times of theta t. Now why I have written 1 minus beta and beta? So beta is the constant that we have taken here, and the value here we have taken is 0.9. Okay, and he this is 1 minus beta, so 1 minus 0.9 is 0.1, again 0.9, 1 minus beta is 0.1. Okay, so this is the same equation that we have written here. Okay, so let's make a box in this equation, so this equation would be somewhat highlighted now. Okay, now what is exactly the significance of writing this constant beta here? Okay, so this question would be probably in your mind, that how exactly you have taken the value of beta to be zero point 0.9 in the previous slide. Okay, now what is the significance of beta? So in the previous slide, what I have written is the value of beta in the previous slide was equal to zero point 0.9. Okay, now what is the significance of this beta? So this beta we can see as Vt as approximately an average over roughly equal to 1 upon 1 minus beta days of temperature. Okay, so what this means, if suppose my value of beta is zero point 0.9. Okay, so 1 upon 1 minus zero point 0.9, so this would be equal to 10. Okay, so if I write beta equal to zero point 0.9, then I am getting a temperature Vt which is roughly approximately average over to 10 days of temperature. Okay, okay, now if I take the value of beta to be a bit close to 1, let us suppose take the value of beta as 0.98. Okay, so what it will be, if I write 1 upon 1 minus beta, that will equal to 1 upon 1 minus 0.98, which is equals to 50. Okay, so if I write the value of beta as 0.98, then it would be 50 days temperature. Okay, or in other words, you can say that you are now taking the average temperature of over to 50 days. Okay, so this curve would be a quite smoother curve. Okay, so now this red curve you can see. Okay, this is the plot of Vt here. Okay, that is the average temperature. Okay, and now if you are taking the value of beta as zero point 0.9, then this is the red curve that you can see here. Okay, now let me change the color of my ink so it would be quite visible to you. Okay, if now suppose that I take the value of beta as 0.98, okay, then what would be my graph be like? Okay, so it would be somewhat like this curve. Okay, the curve in the yellow would represent if my beta value is equal to 0.98. So what is again the significance of writing this beta in 0.98? Okay, so you can see that the graph in red is a bit noisier graph, and the graph in yellow is a quite smooth graph. Okay, so if you are taking an average of roughly over to the 10 days temperature, then you are getting a noisy graph. Okay, and if you are increasing the number of days, that is you increasing the value of beta, and if you're taking an average of 50 days temperature, then you can see that the graph is quite smooth. Okay, so what you are basically doing is when you are increasing the value of beta and taking the value which is very much close to 1, okay, so you are giving more importance to the previous day's temperature. Okay, why? Because if the value of beta is large, then beta would be multiplied with the previous day's temperature, and so you are giving more importance or more significance to the previous day's temperature if this value of beta is very much close to 1. Okay, and we have 1 minus beta, okay, which would be very small ultimately. So you are giving a very much less significance to the previous day's temperature. Okay, now suppose that what I do, if I suppose set the value of beta to be equal to zero point 0.5, which is quite smaller than the 0.98 value. Okay, so approximately how much days temperature average it would be? It would be 1 upon 1 minus beta, which is equals to 1 upon 1 minus zero point 0.5, and that would be equal to 2. Okay, so this temperature now would be approximately average of 2 days of temperature. Okay, so now you are taking 2 days of temperature average. Okay, so in order to represent this in graph, okay, I take another color. Okay, now what is the assumption here, that how would my graph be like? Okay, so if the beta value was near to 1, then the graph was smoother. But if I take the beta value of zero point 0.5 and it is approximately averaging of over to 2 days of temperature, then the graph would be a very noisy graph. Okay, so why this graph would be a very noisy graph? This is because you are now giving quite less significance or less weightage to the previous day's temperature. Instead of give this, you are giving more weightage or more significance to the today's temperature. Okay. So for doing this, the graph would now be quite a noisy one. Okay. So now I hope you have quite clearly understood that what is basically the significance behind writing this beta here and 1 minus beta here. Okay. Now let us move on to the next slide. So thank you for watching this video lecture. I hope this much concept is clear to you. If you need to watch over to more detail that what exactly works behind exponentially weighted averages or exponentially moving averages, then you can watch over to the next video lecture. I hope this much content in the lecture is clear to you. You can like this video lecture. You can comment on this video lecture if you have any doubts regarding this lecture. You can share my video lectures among your community, and you can subscribe to my YouTube channel also. So as soon as a new video is uploaded, you would definitely get a notification for that video. Thank you and have a nice day.